Hi everyone, I'm Wu, and I'm gonna record the homework solution video for question number 7 in homework 9 for the course Probability and Stochastic Processes. So first, the question asks us to show that the random telegraph signal is a strict sense stationary process. So first, to solve this question, first I'm gonna set the xt to be the sense stationary processes. So since xt is the sense stationary process, so we can get that tx of x1, x2 all the way to xn and t1, t2 all the way to tn will be equals to tx of x1, x2 all the way to xn and t1 plus epsilon and t2 plus epsilon all the way to tn plus epsilon. And so here, since the question asks us to show that the random telegraph signal is strictly sense stationary processes, so we need to prove that the probability of yt1 equals to y1 and yt2 equals to y2 all the way to ytn equals to yn will be equals to the probability of yt1 of yt1 plus epsilon equals to y1 and yt2 plus epsilon equals to y2 all the way to ytn plus epsilon equals to yn for any n and t1 all the way to tn and epsilon. So here we're gonna use the properties of a random telegraph signal. So the random telegraph signals probably tell us that the probability of y of tn equals to yn on the condition that ytn minus 1 equals to ym minus 1 all the way to yt1 equals to y1 will be equals to the probability of ytn equals to yn on the condition that ytn minus 1 equals to y1. So we can use the equation and to calculate the substitute this equation into this equation. So we can get that the probability of yt1 equals to y1 all the way to ytn equals to yn will be equals to the probability of ytn equals to yn on the condition that the tn minus 1 equals to yn minus 1 all the way to yt1 equals to y1 times the probability of ytn minus 1 equals to ym minus 1 on the condition that ytn minus 2 equals to yn minus 2 all the way to yt1 minus equals to y1. So times the probability of like this form, but it starts from tn minus 2 and t minus 3 all the way to the probability of yt1 equals to y1. So and the right part of this equation will be equals to the probability of ytn equals to yn on the condition that ytn minus 1 equals to yn minus 1, since we use the equation right here to to calculate this form, to change this form into this form, times the ytn minus 1 equals to y1 n minus 1 on the condition that y of tn minus 2 equals to ym minus 2 times the probability of it starts from tn minus y equals to tn minus 2 and all the way to the probability of yt1 equals to y1. So here I'm gonna set the y1 all the way to yn will be all equals to 1. So we can get the so we can calculate this equation into this form. So the ytn equals to 1 under the condition that yn minus 1 equals to 1 will be equals to e to the power of negative lambda times the tn minus 1 times the cosine of alpha of tn minus 1. So by observing this form right here, we can notice that this equation only related to tn minus 1. So it is not related to the time shift. So since we get this conclusion, so we can get that the random telegraph signal is strict sense stationary processes. So thanks for watching.